Welcome to the LPCXpresso Motor Control Board Introduction and Quick Start video. This video will give you a brief introduction to the LPCXpresso Motor Control Board from NXP and Embedded Artists, as well as a quick start guide to allow you to take the board out of the box and have the brushless DC motor running within minutes. Now we'll look at the overall structure of the LPCXpresso Motor Control Board. One of the strengths of the LPCXpresso board is its flexibility. It directly supports any LPCXpresso target board, as well as any NXP Cortex M0 and PLCC package, or any NXP microcontroller via the expansion connector. This means that a user can use this board with a Cortex M0 for low-end motor control, all the way through Cortex M4 or ARM9 microcontroller for more advanced DSP control. The LPCXpresso motor control board is divided into two sections. The power electronics are on the right-hand side, and the microcontroller control side is on the left-hand side of the board. The board is designed so that the user can separate or decouple the two sides for more design and debugging flexibility. The expansion connector allows any suitable NXP microcontroller to be connected if the user does not want to use an LPCXpresso board. Now we'll look more closely at the left-hand side of the board, which is the control side. First, we examine the supported communication interfaces. There are connectors for full-speed USB 2.0, host device on the go, 10100 Ethernet, and CAN 2.0b. Because the control side depends on the LPCXpresso board or NXP microcontroller that is plugged in, not all of these features are supported. The other serial ports, the RS422-485 interface and the UART-USB interface, which is used to access the MCU's UART via USB, are all supported by every chip or LPCXpresso board. For the user interface, there is a graphical OLED and a 5-key joystick, as well as a reset button. There's also a double EEPROM connected to the I2C port for user configuration or serialization, and a connector for a single wire debug or a JTAG debugger. Now let's look at the right-hand side, or the power side of the board. There are 4 phases that can be controlled by the board, all with up to 100% duty cycle. There are multiple possibilities for voltage and current measurement, including 3-phase voltages and virtual ground, in-phase current on 3 phases, as well as low-side current and input current. Other features include adjustable overcurrent protection, brake functionality, Hall and quadrature encoder interface sensor inputs, and an onboard temperature sensor. The board accepts inputs from 12 to 30 volts and up to 17 amps, controlling motors up to 300 watts. There's an onboard 15-watt power supply that can provide 11, 5, and 3.3 volts. Now that the board is set up, we'll take a look at how you program the board with the example application of the motor control. But before we can do that, you first have to make sure you have the latest version of the LPCXpresso IDE downloaded. If you do not, it can be downloaded for free at lpcxpresso.com. The next step is to make sure that you have the demo code, which is not pre-installed on the motor control board. That can be found at embeddedartist.com, but first make sure that you register your hardware. Okay, so now that you've downloaded the example code and you have the latest version of LPCXpresso, we can get started. First, we will import the sample code from a zip file. Import archived projects in the zip file, and then we have to select the archived file. So it's browsed. And you have to select which archive file you'd like. For this example, we'll choose both the BLD censored and the library. Hit finish, and it'll import all of the code. Now it's been imported. Build all the projects. This will take a couple of minutes. And now you're ready to flash the part. This can be done Ready in Program Flash. you'll see that it says initializing LPC link. Every LPCXpresso board comes with an LPC link, which is an included LPC link debugger on every LPCXpresso board. Select the file. It's under debug, a .axf file, and then run it. And just like that, it loads the board over the USB cable. And now we're done. The board is ready to run. Now let's discuss the hardware itself on the LPCXpresso motor control board. As mentioned earlier, there is a control side and a power side. On the power side, we have a QEI interface, brake control, expansion connector, a Hall sensor interface, the power supply unit, motor winding coils, 4 phases of gate drivers, temp sensor, phase voltage and current measurements, the in-out current measurements and trip, DC current measurements, and of course the motor itself. On the control side, we have a number of communications and debugging interfaces. There's the Ethernet interface, the CAN and RS-485 interfaces, USB interface, there's a socket for other microcontrollers, there's the LPCXpresso socket, a USB to UART bridge, the OLED, and a joystick. And then we have the power supply connections here. And of course we have the separation of the two sides there. Now let's focus on connecting the motor, which comes with every LPCXpresso motor control kit. As you can see, there are 2 connectors as part of the motor. There's a 3-pin, a 3-wire, and a 5-wire connection. The 3-wire and the 5-wire. The 3-wire connector goes into the 8-pin connector. And those 3 pins, those 3 wires go into the 5th, 6th, and 7th slots, yellow, green, blue. Nothing else is connected on the other pins. The 5 wires go into the top 5-pin connector, and they go in red, blue, green, yellow, black, in that order. And that is with the board in this orientation. Now we'll focus on connecting the LPCXpresso. That goes into this connector here. Note there are 2 sets of pinouts. One for the 176X LPCXpresso, which is the top set of pins in this connector, and then the others for the LPC11 or LPC1300 boards. Since the board that comes with this kit is an LPC1114, we will plug in to the bottom set of pins. Once you've connected the LPCXpresso board, you then plug in the USB cable so you can flash or debug your application. Plug in the power supply to run the motor, and then you're ready to go. You just have to hit the reset button. A little introductory text is displayed on the OLED, so that way you know that your program has been flashed properly. Then once it is loaded, you just press in the joystick button. It loads the internal temperature, and then your brushless DC motor begins to turn. Finally, here are some helpful links on where you can get more information on the motor control board, as well as example programs and links on how you can purchase the board. Thank you for your time, and good luck with your design.